All right, guys. So we are going to cover the vocabulary from section 4.1 and 4.2 within this video. So make sure you realize that you can pause, replay, speed up, or just play this video as quickly or as slow as you need to in order to write down these definitions. So what you're going to notice is I've already typed them out just to save the time. And then you guys are going to write them on your notes. So make sure that you are responsible for this vocabulary, even though we're not doing it in the typical format. All right, you have all the access to all of this vocabulary now. All right. So today what we're studying and what this whole chapter is about is triangles. And section 4.1 is all about classifying triangles based off of its sides and its angles. So all of these terms right here under the vocabulary for section 4.1 is about classifying it. So what are the characteristics of each of these types of triangles? And we can classify triangles based off of its sides and by its angles. So there's two classifications for every triangle. So the first one is an acute triangle, and the definition of an acute triangle, or the characteristics, is a triangle that has three acute angles. Now, our next term is an equiangular triangle, and if you would just look at the prefix of equa right here, okay, what that means is equal. And then angular is obviously talking about the angles. So when we're talking about an equiangular triangle, just basing it right off of that title, all right, an equiangular triangle is a triangle that has three congruent angles. Now, I'm going to draw a picture of it. I'm going to draw it really small, all right, off to the side here. But to show that this triangle right here, I'd start obviously by drawing a triangle, is equiangular. You would just show that all three of those angles are congruent, just like that. Okay? Now, our next one is an obtuse triangle, and this seems a little bit different than when we're talking about an acute triangle because this has three acute angles, all right? And we'll discuss this a little bit further, but an acute triangle is a triangle that has exactly one obtuse angle. Now, our last one, based off of the angles, is a right triangle. And this is going to sound similar to the obtuse, where a right triangle is a triangle that has exactly one right angle. And so, once again, if I would draw a picture of a right triangle, all right, we all know what that looks like. But to signify that it's right, I would have to state that those two sides, or the two legs of that right triangle, are perpendicular. Now, these four are all based off of the angles. We're now going to transition into how triangles are classified based off of the sides, and we have three different terms. So if we go back to, once again, our prefix of equa, all right, we have an equilateral triangle, and lateral is talking about the side lengths. So we now have, based off of that term, all right, an equiangular triangle is a triangle that has three congruent sides. So to draw a picture of that, all right, you would draw your triangle, and this time you would mark the sides as congruent. So the notation is important. Now, our next type is an isosceles triangle, and the verbiage of this is very important, all right? So if you look here, all right, there's a key word in here, and it says it's a triangle with exactly two congruent sides. Now, we're going to talk about why that's important in class on Monday, all right? But to draw a picture of that, we would go ahead and draw our triangle and then mark two of the sides congruent. Our last one is a scalene triangle, all right? And a scalene triangle is a triangle with no congruent sides. So in order to show that, you can kind of show it in two different ways, where you could take the time, all right, and show that all three sides of those would be different just by those three different tick marks. Or if you have any type of triangle without any notation, we're assuming that those three sides would be different. So that right there is section 4.1 vocab, all right, all about classifying triangles, all right. And now we're going to go to section 4.2, and the first term in here is our triangle angle sum theorem. So if we just focus on that and we break down that title, all right, first of all, sum means we're going to add, all right, and we're obviously going to add all of the angles within the triangle. And we've used this before in class, we just haven't had the title of it, all right. So what's going on with the triangle angle sum theorem is it says that the sum of the measures of the angles of a triangle is 180, which we've already used and we've already established, all right, in this class, okay? Now, the next term is one that is going to be completely foreign to you, all right? And it's called an exterior angle. And before we talk about the definition, an exterior angle, if we just use what we know about exterior, that means it's going to be an angle that's on the outside of a triangle, okay? Now, within this definition, there is going to be another vocab term that we haven't talked about, and I'm going to draw a picture to show you what I mean, okay? So, the exterior angle theorem says that the exterior angle of a triangle, so a triangle on the outside, is equal to the sum of the two remote interior angles. This right here, all right, is the term that we don't know. And so in order to show you what I mean, all right, I'm going to draw a picture, and I'm going to come down below here. And so I'm going to start by drawing a triangle, okay? Now, in order to draw an exterior angle, all you're going to do is you're going to continue out with one of those sides, all right? So it extends outside the triangle. And then this angle on the outside is our exterior angle, okay? So what this definition says is that this exterior angle is going to be equal to the sum of the remote interior angles. This word remote, if we just think about it in like our daily life, and I said a remote location, that means that that is a location that's far away or away from everything, right? And interior means that they're angles that have to fall on the inside of the triangle. So the remote interior angles in reference to this particular exterior angle are the two interior angles that are furthest away, all right, from the exterior angles. So these are our remote interior. Okay? All right, so once again, all right, the exterior angle theorem says that this exterior angle is going to be equal to the sum of these two remote interior angles. Now, our last two corollaries, so corollaries are like little parts of theorems, all right? I would normally have you guys fill in, all right, what the definitions are once we've established them, and I'm going to kind of do it here. So if you notice here with corollary 4.1, I have not finished this because I want to explain it first. So corollary 4.1 is focusing on the acute angles of a right triangle. So there's a connection between them. So let's say I have, all right, this right triangle. All right, I know it's right because of that perpendicular. And so using the triangle angle sum theorem, I know that the angles within that triangle would have to add up to 180, right? So this x and y are going to represent our acute angles, all right? And I already know that I have 90 degrees taken up from that right angle, which means I have 90 degrees left to share between x and y, which means that x and y would have to add up to 90, which means that the acute angles of a right triangle are complementary. Okay? Now, our last one, and I'm going to explain it, all right, says that there can be at most one right angle and a right triangle. And let's talk about why that's true. So let's say I was trying to draw this right angle, all right, within my triangle, and I mark it as perpendicular. And then I want to draw another one. So let's say I have another one coming up here, all right, another right angle. And so this already is taking up 180 degrees of my triangle. And this then recognizes that I have this open space right up here, all right, where I can't connect that in order to make a triangle because it would make a quadrilateral. So that's why there can be at most one right angle in a right triangle. So I'm going to pause here, all right. We do have some practice problems, but I'm going to make a second video for these.